Sanchayan Maity is presenting What's Next for Bluetooth in PulseAudio. Now, Sanchayan's presentation is pre-recording today, but we are happy to have him appear live at the end of the presentation to take questions. Just a reminder to post questions in Venulus in the Questions tab, which is alongside the Chat tab, and we'll get to those questions at the end of the presentation. Over to you, Sanchayan.
Hello everyone, I am Sanchayan. I work at Asymptotic. We are primarily an open source consulting firm based out of Toronto and Bangalore. Our main focus is on low-level system software, and a lot of our work revolves around GStreamer. Today I'm going to be talking about the work that I've been doing over the last 4 months as part of my work at Asymptotic to improve the state of Bluetooth in PulseAudio. Before that, we will also cover the related terminologies around Bluetooth. So let's get started. So PulseAudio had its initial release in 2004. It first appeared for users of Fedora Linux with version 8. PulseAudio primarily mediates access to the audio resources on your system, so like volumes, routing policy, etc. So let's see some of its features. PulseAudio can take input from multiple sources on the system and redirect them to one or more syncs, thus carrying out the job of software mixing. And this also allows more than one application or program to play back sound at a time. It has per application volume controls. As we saw in audio mixing as well, it can support multiple sources and syncs. It can combine multiple sound cards and synchronize multiple playback streams. It has Bluetooth support. It has command line interface with scripting capabilities. And it has reconfiguration capabilities. Now, PulseAudio works on top of LCA. So in case you are wondering if LCA already exists, why PulseAudio? So LCA is basically advanced Linux sound architecture. It's a software framework and also part of the Linux kernel. It provides an API for interacting with the audio devices or the sound card device drivers. Now, configuring LCA can be tricky. It doesn't have native Bluetooth support. Now, while it does support mixing by something known as a demix, it has a fixed latency, and the program which gets to play back first owns the mixing pipeline. So now let's move on to Bluetooth. So one of the first things whenever we talk about Bluetooth or the Bluetooth stack in general, Bluetooth profiles come up. Now, what exactly is a profile? A profile is basically a behavioral specification which every Bluetooth device must comply or adhere to when communicating with another Bluetooth device. Now, while there are quite a few profiles, we'll look at a few of the common ones. So first is Advanced Audio Distribution Profile, or A2DP. This is what concerns us whenever we are listening to music via our Bluetooth enabled headsets. So it basically allows streaming of audio. Then we have Audio Video Remote Control Profile, or AVRCP. AVRCP allows a single remote control device to control other audio-video equipment in the immediate vicinity of a user. A common use case comes up in car infotainment systems. A more common use case is whenever we are trying to change volume or using the playback control like play or pause on our headsets or via our headsets. That happens with AVRCP. Then we have the headset profile, HSP. HSP allows the use of headsets with mobile phones, Bluetooth headsets with mobile phones. It provides functionalities like ring, adjust the volume, accept a call, or being able to hang up on a call. Then we have the hands-free profile. Hands-free profile allows the use of hand-free kits with mobile phones. In comparison to HSP, it provides some more features. So it provides for a better audio quality in comparison to HSP, as it uses a different codec in comparison to HSP. And it provides some other features like voice dialing, call waiting, or redialing the last number. So henceforth, for the purposes of this talk, we will mainly be focusing on A2DP. So let's talk about codecs next. So what exactly is a codec? A codec is primarily hardware or software which encodes or decodes digital audio. And in our case, the primary job of a codec is compression so that we can make the best available use of the bandwidth that we have in case of Bluetooth. Now, in the context of A2DP, there are a few codecs. So the first one is the low complexity subband codec or SBC. Now this is the codec which is mandatory for the A2DP profile. So any device which supports A2DP profile must have support for SBC. Then we also have a few other optional codecs. There is audio processing technology or aptX. Then we have advanced audio coding or AAC. AAC has been standardized by ISO and IEC as part of the MPEG-2 and MPEG-4 specifications. And then we have LDAC. Now, while SBC is mandatory for the A2DP profile and is available on every device which supports A2DP, the others are not found on all devices. aptX is from Qualcomm and is generally found on devices which use Qualcomm chipsets. Apple devices generally use AAC. LDAC is from Sony, and Sony markets or targets it primarily at audiophiles. So we have all these codecs. So which is better? Now we live in this funny XKCD world where we have quite a few codecs first of all. So there are other aptX variants like aptX adaptive or aptX low latency. Then there are variants of SBC like fast stream, which gives a better audio quality for HSP, or HFP uses the variant of SBC called MSBC. Then there are some newer codecs from Samsung and Huawei, though these are not available on many devices yet. So among these, which is better? Now let's look at SBC. Now while SBC is the mandatory codec for the A2DP profile, the A2DP profile specification does not lay out any mandatory guidelines. It only gives certain recommendations. So these codecs also have something known as the codec parameters, which allow, or basically it influences the behavior, the encoding quality of the codec. So one such parameter when it comes to SBC is known as bit pool. Now, while it is possible to set the highest value for bit pool to achieve the best quality, however, the operating system Bluetooth stack might not support that, and it has been observed that a lot of Bluetooth headset manufacturers set the bit pool value more conservatively, and thus we see a lot of variation when it comes to the encoding quality, the output of the encoding from SBC, and thus SBC is the best and the worst codec at the same time. For aptX, there are no codec parameters to configure. Qualcomm provides a reference implementation, and that's what the user or the manufacturer gets. In case of LDAC, LDAC, as we talked about, is from Sony, and based on the test done by the folks over at Sound Guys, it has been observed that it can provide better quality in comparison to aptX-HD. Now, AC is supposed to provide a quality very close to the original. It takes into account something known as the psychoacoustic profile. However, it has been found that Apple devices have the best encoder implementation, and thus the AC output is the best on Apple devices. The second best is with the Fraunhofer FDK library, which has been developed by Fraunhofer IIS and is included on Android. However, again, based on the test done by the folks over at Sound Guys, the AAC encoding output on Android phones has been observed to be not on par with Apple devices. Now, this is definitely not due to any fault of the codec for sure. Probably there are it is due to the library implementation or the different codec parameters being used. Now, another factor or another distinguishing characteristics of these codecs is latency. Now, why does latency come into picture? The time it takes for a processor to do the decoding can delay the encoding output to a point where one starts observing lip sync issues, and this can especially happen while watching videos. Now, math and computationally intensive codecs like AAC tend to have higher latency, while codecs like aptX, which are not so math and computationally intensive, have been observed to have lower latency. So let's look at a graph from the test done by the folks over at Sound Guys. This shows the codec latencies on the various devices and among the codecs themselves. So if we look at Google Pixel 3, you can see that AAC has the highest latency in comparison to others. However, if we look at the other devices, there is a range of variation among the codecs themselves on the same device and among the devices. So OnePlus 6T performs closely to Google Pixel. However, the Huawei Mate and the Samsung Galaxy show a lot of variation among the codecs themselves and also in comparison to the other two devices. So on the basis of this, we can see that we cannot say for sure that a codec on a particular device is always going to give the best possible output. There are a lot of factors that we need to consider. So the CPU on the device can make a difference. The buffer sizes can make a difference. The codec parameters and the codec library itself that is being used for the codec can also make a difference. And that's how the state of things are when it comes to codecs. So let's come back and have a look at the current state of things in PulseAudio. Sadly, upstream only supports SBC. Other codecs have not been supported or are not supported upstream so far. HSP and HFP support is available. However, the sound quality has been a pain point for a lot of users when using HSP or HFP. There have been community efforts to add support for the other codecs. So for example, there is the PulseAudio modules Bluetooth project which adds support for aptX, LDAC and AAC. Another implementation was submitted upstream. However, there have been challenges in getting these merged upstream. Then there is something known as the messaging API which only very recently got merged. Now, while PulseAudio has had something known as card profiles, which allows some semblance of a selection to the users. However, the card profiles are not a good fit for every use case, and the messaging API was written to address this. We'll see in a bit why messaging API is important to us or concerns us. Now, what were the challenges? Now, while we do want to support the various codecs, we also want to allow users to select among them. Then we need to think about patents or licenses when it comes to the codecs. In case of aptX, the patents seem to have expired. However, a license is required from Qualcomm. For AAC, at least from the user perspective, no license is required for streaming or recording the content. LDAC. Now, LDAC is from Sony, and there is a reference encoder library implementation available, and it is packaged in Android, available under the Apache license. However, there is no decoder implementation. So, when considering any of these codecs, we need to think about patents or the licenses. Now, what if you want to support multiple encoders or decoders for a particular codec? Now, as a regular desktop user, this might not concern us, but this might be helpful for system integrators, which can allow them to select a particular codec library based on the platform under their consideration or as per their use case or requirements. Now, just as with many open source projects, and more so for core system projects, currently PulseAudio is being maintained by 3 people in their own spare time, which probably does not amount to even a full-time developer. And for a project, the scope and size of PulseAudio, this is definitely not enough. So we definitely need more contributors. We need more people who can help review the code and testing as well. So let's talk about GStreamer for a bit now. GStreamer is a pipeline-based multimedia framework. It allows the application to be separated from the underlying concerns or complexities of encoding, decoding, or streaming media. Now, why are we even talking about GStreamer, and especially in the context of PulseAudio? Or what does GStreamer gives us? So let's look at that through an example. Now, here what we have, what in GStreamer terminology is known as a pipeline. And this so-called pipeline has 3 components, or in GStreamer terminology, what are known as elements. So I have an audio test source element, I have an LDAC encoder element, and I have an A2DP sync element. The audio test source element basically gives me raw PCM audio data. It primarily generates a test sine wave tone. The LDAC encoder takes the raw PCM data and gives me the encoded audio output via LDAC encoder. And then we have the A2DP sync, which takes care of streaming this encoded audio via Bluetooth. So we have these 3 elements. Now let's look at the pipeline a bit in more detail. So first off, we have the GST launch. GST launch is a command line tool which allows to build pipelines and test them on the command line. -v is just a flag telling GStreamer that I want verbose output. Then we have our audio test source element, which gives us the test sine wave tone and basically the raw PCM audio data. Now, element descriptions in the pipeline are separated by exclamation marks. Next, we have what GStreamer calls caps. A caps is basically a specification which tells the element coming before it or to some extent after what exactly is required, or it basically influences the behavior of the element. So in this case, the cap specification says it tells audio test source to first of all give raw PCM data, which is audio X raw, to do so at a rate of 44.1 kilohertz, 2 channels, basically stereo, and the format should be S32LE. S32LE basically means that my PCM sample should be represented by 4 bytes. Next, we have the LDAC encoder. Now, LDAC encoder has a equimate is equal to 2. This is a property is equal to value specification. Properties basically allow users to set some kind of parameters on the element. In this case, the equimate property basically influences the bitrate of the LDAC encoder. Then we have the A2DP sync. The A2DP sync takes the encoded audio and transmit it to a Bluetooth device, and the transport is equal to what you see here. Basically says that it should do so to a device with this particular address and on a certain file descriptor. So what we have here is a pipeline which takes a test sine wave tone and streams it via Bluetooth. And as you can see, nowhere in this have we concerned ourselves with the underlying implementation detail of what the buffer sizes are or how exactly the data should flow between the elements, or setting up the transport bits for streaming or any of those things. So GStreamer basically abstracts all these details out from the developer or end user, and this abstraction is helpful to work with anything related to audio, video, or streaming. And that's why we are talking about GStreamer in the context of PulseAudio as well, so that while implementing the codecs in PulseAudio, we do not want to concern ourselves with the underlying details of each codec. And for example, if we look at this pipeline, instead of the LDAC encoder, if I were to replace it with an aptX encoder or an AAC encoder, I will get audio which is encoded by aptX or AAC, and without changing much of anything else. And that's a lot of power which GStreamer gives us. So that's why we are considering GStreamer here in the context of PulseAudio. Now, as a disclaimer, this is not the exact pipeline that is used in PulseAudio to implement LDAC. So PulseAudio definitely does not use the audio test source. The raw PCM data will come from the devices which interact with PulseAudio. Then we do not have the A2DP sync as well. PulseAudio takes care of setting up the transport related bits by itself, and definitely has the LDAC encoder. So that's what GStreamer gives us. Now, what has been the progress so far? First off, we wanted to support LDAC. Now, as we talked about in the codec section, there is a libLDAC reference encoder library available and packaged with Android. LDAC support was not available in GStreamer, so we first implemented the LDAC encoder plugin in GStreamer, and this took around a month of work in September, and this was accepted upstream by the end of October. So GStreamer 1.20 should come out with LDAC support. Next is AAC. Now, there are different AAC variants, so to speak of, and if one wants to use AAC over Bluetooth, a particular variant called low overhead MPEG for audio transport multiplex or LATAM comes into picture. Now, while GStreamer had support for AAC via 3-4 different plugins, none of these plugins supported LATAM. So we first implemented LATAM support with AAC in GStreamer, and the AAC specification is quite complex. So we had to understand the specification, understand the current state of support and implementation in the various plugins, and then implement LATAM for one of the available encoder and decoder plugins, while making sure that we are not breaking anything else in the process. So this is currently under review. It hasn't been merged upstream yet. As I mentioned, AAC specification is quite complex, so we are waiting for a review, but we are hoping this should be merged sometime in the future. Coming to aptX. Now, GStreamer already supported aptX via the FFmpeg library based plugins. However, we observed issues related to delays and stuttering while using the aptX encoder and decoder via the FFmpeg based plugins. There is another library called libopenaptX, which also provides support for aptX. And just around this time, a GStreamer plugin, which was based on libopenaptX, was written and accepted upstream. And we were able to include this and provide support for aptX. Then we had to implement codec switching. And just as we talked a bit earlier, this is where the messaging API comes into picture. The codec switching is implemented using the messaging API. We had a proof of concept running with all the codecs via GStreamer. And as the time of this recording, a merge request is currently open in PulseAudio and under review. We are hoping sometime down the line this should be merged upstream, and then PulseAudio would have support for the various codecs via GStreamer. Now what next? So once the codec support is available and accepted upstream, what are the things that we would like to have next? Now, LDAC has something known as adaptive bitrate. It allows for changing the bitrate depending on the transmission conditions. We would like to support this. HFP profile provides better audio quality in comparison to HSP. HSP uses the CVSD codec and it does not provide as good an audio quality as expected. And HFP uses MSBC, which gives better audio quality in comparison to CVSD. Now, there is already a merge request open upstream, which adds support for MSBC. It would have to be rebased on top of the current codec support that will be merged eventually, but this should happen sometime down the line. Now, the latest Bluetooth specification is 5.2 and introduces a successor to the SBC codec known as LC3 or Low Complexity Communications Codec. This should start appearing in devices maybe within a year or so, and we would like to support this. And then some user-facing improvements like allowing users to specify the preference order for codecs. Now, PulseAudio is network capable, so two machines on the same network running PulseAudio. One machine can stream audio to another machine and play sound from its speakers. Now, for this particular use case, we would like to support Opus. Opus is another codec which has some desirable properties for use cases like this. That's all, folks. That's what I had for today and for this talk. Let's move on to questions.
Excited to have Sanchayan here with us to take live questions all the way from Bangalore in India. Welcome.
Thank you.
Okay, so one of our first questions coming up here is, how do you compare the quality of the codices when measurement is actually used to calculate quality?
Okay.
That's a good question.
Okay, yeah. So while we definitely haven't measured the quality ourselves, there are 2-3 factors. One is how much distortion the codec might introduce for a particular setting at either the low end of the spectrum or the high end. And then the actual encoding output that comes out, how much of it is actually close to the original input that was given. So for example, this is generally compared on the frequency spectrum, and you can see if the codec introduces more quantization noise and things like that. So those are the few of things which are considered when comparing the codecs.
Okay. All right, so we've got some more coming in here. Next question. BT5 finally adds multi-profile devices, so having A2DP send and receive for mic and headset is finally possible. What is being done to support this functionality in endpoints that support it?
Okay. So I have to say that, yes, the Bluetooth 5 specification is out right now, but we haven't started doing any work in PulseAudio yet. when it comes to Bluetooth 5, because Bluetooth 5 changes quite a bit of things, and it has some different profiles. It has a different mandatory codec for the A2DP profile. So this work hasn't really started yet, so difficult for me to comment much more than that. But we are hoping that whatever is required, we should, eventually should be able to support that.
And are you sort of expecting this in the near future, or what sort of time frame are you looking at for that?
So right now, the Codecs work has actually just got merged last week. So there will be a certain time window when that work itself will see some bug fixes and improvements, and then it gets finally released. I'm hoping before sometime before the mid or by the mid of this year, and then finally, I think then we start or looking into things what are required for the new Bluetooth 5 spec.
Okay, next one is a long one, bear with me. With regards to HFP MSBC, there has been an effort by one user to try and upstream support to PulseAudio plus kernel to basically just get the microphone to work at all, with many headsets such as Apple AirPods. It seems stalled upstream in the kernel side not wanting to merge it. Do you have any insights into that problem, and if it might get solved by someone taking a different tact with upstream, or how likely that is to actually get fixed?
Okay. So I have not been tracking what has been happening on the Linux kernel side of things, but I know another user who I have also been coordinating with for this recent work which got done. So I think he had got MSBC recently working on top of all the recent changes that went in. So I haven't checked in on the details, but I think there probably should be some good news there, though I'm not sure what is happening on the Linux kernel upstream side of things. From the PulseAudio side of things, I think at least one developer has got MSBC working on his setup recently. So I'm hoping there's some good news there in the future.
Okay, all right. So there's been a bit of chat on the Venulous chat, which is great. I don't have any questions just coming in at the minute. Is there anything else that you wanted to add to your presentation?
Yeah, so I did a recording of the presentation, so there has been an update.
Oh, just a little bit frozen, but hopefully we'll have you back in a sec.
Okay, yeah. Am
Yep,
I
you're
back?
back.
Yeah,
You're back.
yeah. So there is an update in that the codec work has actually got merged last week, and I think the next release, which should happen maybe before the mid of March, should have support. PulseAudio should have support for the new codecs. However, since we are also dependent on GStreamer, so the GStreamer release will happen probably a bit later. So I think before the mid of this year, I probably all things should be in place both in on the PulseAudio side and the GStreamer side, so that users can have access to the all the codec support in PulseAudio.
And where do you see this sort of heading in the future?
Sorry?
Where do you see this heading in the future?
So after this, obviously there will be some time frame where distros will start landing the actual release, start packaging the actual release, and on both the GStreamer and the PulseAudio side. And there will be some time frame where we will start getting bug reports, or generally as it happens, other issues being reported by users, which we will have to look at. And after all that, I think, as I mentioned in the presentation, the next parts come in like MSBC support, starting work on the Bluetooth 5 spec so that we can support the newer codecs and profiles, and a few other things.
Sounds like there's quite a bit happening.
Yeah.
Okay. All right. I think that's all we have from attendees at the moment. Are you happy to take any discussion or questions from attendees in the post Q&A room?
Yeah, I will head over to the post Q&A channel, and I will be happy to take questions. I will be available till the end of the conference there.
Thank you so much for joining us. It's been really great to have you live after the recording. It's always exciting to chat to the presenters. We're going to take about, I think it's about a 20-minute break now, and we'll be back at 4:40 for our final talk with Tim Sarong, presenting on containers are hideously undebuggable, black boxes, and we never should have invented them. So that's up next. But once again, thank you, Sanchayan, for joining us.
Yeah.
Thank you.
Thank you, everyone.